Hey everyone, welcome. Today we're going to tackle a classic mix-up, something that trips up pretty much everyone, mass versus weight. You might think, hey, they're the same thing, right? But in the world of science, they are worlds apart. So let's break it all down.
So, think about it for a second. Every morning, maybe you step on a scale to check your weight. But what if I told you that number you see, it isn't really your weight? No way. That scale is actually measuring something else, a force, and then it's just doing a little quick math behind the scenes. In this explainer, we are going to crack that puzzle wide open.
Okay, so let's dive right in. To really get to the bottom of this whole thing, we've got to start with the absolute basics. First up, what exactly is mass?
You know, to put it simply, mass is just the amount of stuff an object is made of, the matter inside it. It's the very essence of what you, or a chair, or a planet is made of. And in physics, we like to keep it simple, so we just call it m.
So how do we measure all this stuff? Well, there are a few different units out there, as you can see. You've got pounds, you've got grams, but the one we really care about, the big one, the international standard for all things science, is the kilogram, or, kg.
All right, so that's mass. Pretty straightforward, right? It's just the amount of stuff. But to get to weight, we need to add a whole new ingredient to the mix, a powerful, invisible force called gravity. And right here, this is the crucial difference. Weight, which we'll call W for short, isn't the stuff itself. Nope, it's the force of gravity acting on that stuff. It's the pull. Just think of it like the Earth is constantly giving everything a little tug, pulling it down towards its center.
And the best part? The relationship between them is actually beautifully simple. The formula is just this. Weight equals mass times g, and g is just a number that represents the acceleration due to gravity. So you can see, right? The more mass something has, or the stronger the gravity is, the more weight it's going to have. It's a perfect little partnership.
Now here on our home turf, on Earth, that gravitational pull is super consistent. The value for g is always 9.8 meters per second squared. You should probably remember that number. It's like the magic key for turning any mass into its proper weight, right here on our planet.
And get this, since weight is a force, we don't measure it in kilograms. That would be wrong. The standard unit for any force is the Newton. Yep, named after Sir Isaac Newton, the guy who kind of figured this whole gravity thing out. So let's lock this in our brains. Mass is kilograms. Weight is newtons. Got it? Good.
All right, we've met the contenders. Now it's time for the main event. It's the head-to-head showdown, mass versus weight. I promise you, this is where it's all going to click into place.
Let's start with the absolute core difference, the big one. On one side, you have mass. That's the amount of matter inside an object. On the other, you've got weight, which is the gravitational force acting on that object. So one is what you're made of, and the other is just how hard the planet is pulling on you.
Okay, now this next point, this is the real game changer. An object's mass is constant. It never, ever, ever changes. It doesn't matter if you're on Earth, on the moon, or just floating around in deep space, the amount of you is always the same. But your weight? That's a whole different story. Your weight can change all over the place, because it completely depends on how strong the gravity is where you are.
And here's a little something for the science nerds out there. Mass is what we call a scalar quantity. That just means it's a number, that's it. Like 10 kilograms. Simple. But weight is a vector. That means it has a number and a direction. And for weight, that direction is always the same, straight down toward the center of whatever massive thing is pulling on it.
Okay, enough with all the theory, right? Let's make this real. It's time to actually crunch some numbers and see how this all plays out in the real world.
Okay, let's take a car. A pretty standard car. We know its mass is 800 kilograms. So the big question is, what is its weight right here on Earth? Well, it's pretty simple actually. We just pull out our handy formula, weight equals mass times g. So we just plug in the numbers. We've got 800 kilograms for the mass, and we multiply that by our magic number for Earth's gravity, 9.8.
And the answer is, drumroll please, 7,848 newtons. And notice what I said there, newtons, not kilograms. That number right there, that's the actual force the Earth is using to pull that car down toward its core.
Whew. Okay, we've covered a lot of ground here. So let's boil it all down. What's the one key takeaway? The most important thing you need to remember from all of this?
So, the crucial point is, if you remember just one thing from this whole explainer, make it this. Mass is the stuff. Weight is the pull. Your mass is always the same no matter where you go in the universe. Your weight, yeah, that can definitely change.
And that brings us to one final thought experiment. Let's say you traveled all the way to the moon, right? Gravity is way weaker up there. So, what would change? Your mass or your weight? Go on, think about it for a second.
The answer, of course, is your weight. You'd feel incredibly light. You could bounce around like those old videos of the astronauts. But your mass, the fundamental amount of stuff that makes you you, that wouldn't change one single bit. And that, right there, is the essential difference.